Okay, so today we're going to talk about proportions in triangles. Okay, so proportions in triangles are basically three, I think, different kinds of situations. The first one we're going to talk about is called the Side-Splitter Theorem. And what this says is that if you have a triangle and you have a line, or a segment rather, that is parallel to one of the third sides, then it says that it splits the sides up proportionally. So if I were looking at this scenario, I would have like side A, side B, side C, and side D. So I could set up that A over B would be equal to C over D. Okay, so let's think of a scenario when we have, so you have to know that the lines are parallel. So if we have, let's say, 9 and 4x minus 2 and 12 and 3x plus 2. Okay, because we have parallel lines, I know that it splits the sides proportionally. Remember, there's a lot of properties of proportion, so as long as you're consistent, you're fine. So 9 over 4x minus 2, that should equal 12 over 3x plus 2. So then we're looking at algebra. I'm going to zoom in here a little bit. So then we're going to do our algebra. Remember, if you have a binomial in the numerator or denominator, that it's understood to have parentheses around it. So that way you get the distributive property when you are doing the product of proportions, or the cross multiplying. So 9 times a quantity of 3x plus 2, that should equal 12 times a quantity of 4x minus 2. Now it's just algebra. So 27x plus 18, doing the distributive property, that should equal 48x minus 24, doing the distributive property on that side. I'm going to subtract 27x on both sides and get 18 to equal 20, is that a 7? Yes, that is a 7. So 21x minus 24. I am then going to add 24 to both sides, and I get 42 equals 21x. Divide both sides by 21, so x would equal 2. So if I wanted to find the missing lengths, I could plug them in, put a 2 in here. 3 times 2 is 6. 6 plus 2, this would make it 8. And if I plugged a 2 in here, that would be 8 minus 2, which would be 6. So a way to check this is to check to see if your proportions are in fact, or if your ratios are in fact a proportion. So 9 over 6 should equal 12 over 8. And if you do the means and extremes, you do get 72 equals 72. So it checks. Okay, so that's one scenario. We could use the same idea if we just have parallel lines. So using kind of the same idea with side splitter, but not having it in the form of a triangle. I'm definitely exaggerating the space in here so you don't think that they are equal spaced. If I have a transversal cutting through, and I know that these are parallel, it is going to divide them proportionally. So if I have, let's say this is, whoopsie, this piece here is x, and I need another transversal in here. Okay, so this piece here is x, this piece here would be, we're making 70. And from, let me get a different color out. From here to here, we are going to make it 62. And one more color. From here, this paraline to this paraline, we are going to make this one 56. So just using the side-splitter theorem or something very similar to it, it's going to break the lines up proportionally. This is just, like I said, in addition to the side-splitter. So this piece of x is to this piece of 62. That should equal this piece of 70 over this piece of 56. Okay, so means and extremes. 56x equals 70 times 62. Let me get out my calculator. So 70 times 62 is 4,340. Now I can divide both sides by 56. So x equals 77.5. Okay, so same idea as the side splitter. The next one we have is called the triangle angle bisector theorem. We have the triangle, I'll just write it out. Triangle angle bisector theorem. So if you have a triangle and you know that that segment is an angle bisector, move this up. So you know that the angle is bisected. Make that A, B, C, and D. So if this is an angle bisector, then A over B would equal C over D. So if I put this with a real problem, oopsie, sorry, it's crooked. Okay, so we have to have an angle bisector. And we have x, 9, 25, and 15. So setting up my proportion, I can do x over 9 equals 25 over 15. Means and extremes, I have 15x equals whatever 25 times 9 is. Oopsie. And we have 225. I have no idea why I used my calculator for that. Divide both sides by 15. And x is going to equal 15. Okay, so those are the types of problems that you are going to see on your worksheet for tomorrow. There's one other little, oopsie, there's one other little piece that I want to add on there that you may need to remember, is that if you have a triangle, no matter if we're talking about side splitter or whatever, we're going to make this into this kind of a problem. If I know that this entire piece is 24, for example, and I know this is x, then what is this segment going to be? So this is going to be bringing back into the picture the segment addition postulate. If I have a segment that is a total of 24, let's say, inches long, and I know that, say, maybe this one is 10, then how would I find out how much that is? Well, it's going to have to be whatever 24 minus 10 is. Or you can think of 10 plus what would equal 24. The answer is going to have to be 14. So if we use that same idea over here, this piece is going to have to be 24 minus x. And so you're probably going to need those to be helping you set up some information in your proportions.